Hello everyone and welcome back. In this bonus video I want to talk about collision and flip simulation, and something that you can use in your setup, and especially if you have assets that are coming from the modeling and also animation. And sometimes these kind of models are not really tight for the simulation, or maybe they are high res, and that can really slow down the entire process. So I want to show you few workflows that actually I use in production, and also in any setups that I need to create for my client, or for my personal R&D. So let's say that we have, in our case, whale object that is it's animation, and it's coming from our animation team. And let's say that this model is now, it's like mid-res in terms of polygon count, but let's create it to be like really high-res model. So let's say this is our final asset that we are getting from our animation team, especially if you need, if animation team also animate some wrinkles or some small maybe eye movement, stuff like this. But this kind of model is going to be really slow to process in a flip simulation. And also we don't need so many details because we are going to create VDB. But sometimes for calculating velocities from this object can be slow, because like I said, this object is really high res. So the idea is to create proxy geometry and to transfer animation from high-res model to proxy geometry, and something that can speed up our entire workflow. So first thing, I want to create proxy geometry. So first thing, I want to get initial frame. So in our case is frame 1. So if we go back, so this is our starting point of our whale. So I just want to create proxy geometry, more or less like low res or mid res objects. So first I'm going to create VDB from that object. Then I'm going to add just a bit of dialect to scale this volume more, so it's just really tiny difference. And then I want to create convert to polygons, but using adaptive options. So if I convert to polygon without adaptive option, as you can see, we still get high res poly count. But if I use adaptive option, in this case let's put 0.1, but you need to find the best value for your object. So we get proxy geometry for our whale, and comparing to high res one, as you can see, okay, let's go back to frame 1. As you can see, it's a lot different. And if we calculate the poly count, so it's like 343 comparing to 16,000 polygons, and it's like 20 times less in a polygon count. So the next step, we need to also create a rest frame, because we are going to use point deform. So this is the first input is our mesh to deform. The second input is actually rest point lattice. So our point lattice is actually the points of our high-res object, and the last one is actually deformation point, so it's actually our animation. So but the second input need to be the rest point. So the same one when we did the proxy mesh, it's going to be time shift. So proxy 1, so the rest, so for time shift 1, and then we are reading the high res animation. So without point deform, as you can see, we are transferring our animation on the proxy model. And after that, we are going to cache. That can be Alembic or BGO, it's up to you. So when we cache, so this is our proxy animation that is completely matching with our high res. As you can see, it's overlapping without any problem, but it's a lot easier to move and do everything inside the Houdini. As you can see, this is a lot slower, okay, especially because we are adding subdivision. But in terms of cache, as you can see, the high res, the proxy model is now a lot lighter in terms of size, and also it's easier to move inside of Houdini. The next step, after you do the proxy geometry, especially in the flip simulation, we need to have proper substeps. But if we use, like, if we cache our geometry as a sequence of BGO file, there is no information about subframes. So if we go here and uncheck the integer frame value, and if we move, you will see that there is no subframes movement, and it's only frame by frame. So you see, and that can be a problem when we have substeps in our flip simulation. So one way to solve is to adding default time blend node. So when we add time blend node and we're now moving, you can see that our now animation is moving every substep. And now if flip need, because they're in a static object, there is a interpolation check button that you can use to get proper subframes or substep for your mesh, for your animation. But without time blend, that is going to be like step only, but every single frame without any in between values. So that's like first step when we load our proxy geometry. After that is the same workflow like we use on the whale jump. So it's calculating our velocity. So we can see these are our velocity from our whale, and then it's creating VDB, and we can save that to hard drive with proper substep. But this is much easier to move. And now if I want to use, like, for example, point velocity or our high-res object, as you can see, it's a lot slower to calculate velocities, and this is something that we really don't need, because it's really hard to catch every details in a flip simulation, only if our flip is really high res. But creating proxy geometry can speed up our workflow. And let's say that animation team change the animation, so only thing that you need to do is to load new animation and just resave new proxy geometry, and all the setups are going to be the same, because the proxy geometry is going to be the same. The only thing that we change is actually animation. So this is for deforming object, like character or some rigid body, if it's not already simple version. The next thing is we are going to try on a static object. So for static object, it's also depend what kind of model we are going to get from our modeling department. So in this case, I'm going to use this high-res ship model, with a lot of details. So let's say that we need to use entire ship also with the sails and the ropes, and with everything in our simulation. So I will just going to optimize this model to not use entire geometry. So in our case, I'm just going to use ropes, like hull model of our ship, and also the sails. So if we just use this object and just convert to VDB, you will notice a lot of problems here. So if I just want to convert this to geometry and just want to see how this actually look when I convert to polygons, as you can see, there is a lot of problems with our model. So because the modeling department sometimes doesn't build watertight object that is really important for our simulation, because we need to use volumes for our collision. So there are a few tricks that you can use. So sometimes you need to use others, but most of the case, these workflows that I'm going to share now are going to cover 90% of creating good and proper collision objects. So first thing, let's say we have a sails. So if I just convert to VDB, there is nothing going to happen, because our sails are open geometry. There is no thickness. So one solution is to extrude our sails, but that's also going to add more polygons. The other solution, and it's something simple, is to scatter points on our sails and actually use VDB from particle fluid to convert actually into VDB, something that we are doing when we are doing the mesh process. So when we convert this to polygons, just to see how all this is going to look, it's actually we get nice and proper sail. And if we just use VDB from polygon, as you see, there is nothing happening. So for the for the objects that are open, like grid, plane, or stuff like this, or sail without any thickness, we can use scatter and VDB from particle fluid, and we get, for example, we can name it surface. So that's let's say for the sails. Then let's say we have ropes in our case, so the same problem. If you use VDB from polygons, the VDB it's not going to convert all the geometry proper. So if we convert to polygon just to see what is going to happen, as you can see, comparing to the original one, a lot of stuff are missing. So one solution is also that we can use, so let's remove this VDB from polygons for the sail. So again, we can use again the scatter. So this time scatter points everywhere, so crazy amount of points. And then again we can use VDB from particle fluid, change this name to surface, and then we can convert this like we are using for the fluid. So it's just going to take a bit of time now, because it's a lot of points. And so we can do change the droplet scale like 0.5. And then now if we do convert, just to see how these look now, if we use convert to polygon, so there is, you can see we need a bit more detail. So one way we can use, for example, VDB reshape node, just to dilate our VDB, and it's much better now without going crazy particle separation. So if we compare these two now, so we can maybe use like smaller value, something like this, but there are problems here. So maybe 0.1, or instead of we can add maybe a bit more points to entire process, just to have better creation of our surface field. And now if we compare this workflow to the VDB from polygons, the standard one that we use, it's completely different. You can see a lot of problems. So one solution is this, but like I said, we need to play to find the proper radius and everything. But if we make it larger, it's not going to impact our simulation that much, because so let's see the final value, for example, here. And now we have like sails, and we have like ropes, and the last one is entire ship. So if I just use again VDB from polygons, as you can see, it's not going to convert properly, because in our case our object is open somewhere. So if we go back here and if we try to visualize where our object is maybe open, it's really hard to find. Maybe we need to merge some vertices or points. So one simple node like polyfill, like single polygon, for example, it's going to help us to fill these open areas. So when we use convert VDB from polygons, so let's add a bit more detail. Now we have proper collision object for our flip. Now if we want, so idea is we can load all these separate, or like I said, we can combine them and create one single VDB. So it's up to you. So if we want to create one single VDB for our simulation, so we can use VDB combine. So let's put VDB combine here, and SDF union, and then also SDF union with a ship. So now if we compare, so this is our collision, how is our collision is going to look for the flip. And let's reorder, you know, this stuff just to be better. So this is our final VDB, and if we're going to check something that we get, you know, or use by default, you can see it's going to be a lot of problems to use this proper for the flip simulation. So this is like, you know, separate process how you can prepare your geometry, you know, to be better for the flip simulation and to avoid any problems. So the next step, you know, if we need to do this like we did for the whale jump, like we need to save VDB for, you know, every frame, that can be, you know, crazy. And especially if you have object that is not deforming. So I'm talking about, let's say that our sails in our case are not moving, so the sails, an entire ship animation, there is no animation of the ropes or, you know, sails, so it's more or less just entire object is moving, you know, like here. So in our case, it just, you know, entire object is moving. So let's say spaceship or, you know, car. So there is no opening of the doors, breaking glasses, you know, stuff like this. We can actually minimize the VDB, you know, VDB conversion per frame. So let's say that, you know, this is our object now. So let's remove this. Our object with animation. So now let's put, you know, something like object obj, and this is going to be, you know, our VDB. It's going to take a bit of time just to finish. I mean, you can save this VDB to hard drive. So we have VDB, and these are our initial, but we animate, you know, our ship to do, you know, some movements, you know, like this. So the one thing is that we can do is, again, you know, point velocity to calculate, point velocity to calculate, you know, proper velocity for our object. But if we now want to use, you know, if we need to convert VDB per frame and use all these steps, it's just going to take a lot of time. So if our object is just doing transformation and rotation, what we can actually do, we can actually do, you know, create initial VDB and use the same animation that we are doing for the object to actually move our VDB. As you can see, even if we use stuff like, you know, subframes, they are going to work, because actually we are using transform node, which has, you know, proper subframes for transformation. So our VDB is going to work. So actually, after that, we are going to use, you know, this geometry. So this is going to be like a collision geo for flip, and this is going to be our collision VDB that we are going to load in static object. So this is what we are going to load properly now in static objects, so collision geo and collision VDB. So if you have, like I said, object like spaceship, you know, just, you know, non-deforming animation, just, you know, translate and rotate. In this case, this is one workflow that can really speed up, you know, entire process, especially if your object is really high res with a lot of details. So VDB per frame can actually, you know, cost you a lot in terms of creation and memory and, you know, disk space. So this is one workflow that, you know, I use. For example, when I did my spaceship R&D, this was the workflow that I use, and I minimize, you know, my simulation and disk, you know, space, and also conversion time drastically. So hope you like these two, you know, tips, you know, for collision. One is for deforming, creating the proxy, and the other one is if you have really crazy object with open edges. So, you know, workflow that, you know, can create your proper collision, and and save you a lot of problems in simulation. Okay guys, see you in the next one. Bye.